objectives. At the end of the course, the user will be able to know about transaction recovery, understand the concept of system recovery, understand the concept of SQL support in backup and recovery. Introduction to backup and recovery. Backup and recovery. A DBMS must provide facilities for recovering from hardware or software failures. The backup and recovery subsystem of the DBMS is responsible for recovery of data failure. If the system fails in the middle of a complex update transaction, database backup. A backup is copying or archiving of files and folders to restore them in case of data loss. A backup is also known as a copy of the data. This copy can include important parts of the database such as the control file and data files. A backup is a safeguard against unexpected data loss and application errors. If original data is lost, then user can reconstruct it by using a backup. The reconstructing of data is achieved through media recovery, which refers to the various operations involved in restoring, rolling forward and rolling back a backup of database files. There are 4 types of backup available: physical backup, logical backup, remote backup, consistent and inconsistent backups. Physical backup. Physical backups are the backups of the physical files used in storing and recovering the database items such as data files, control files, and archived redo logs. Every physical backup is a copy of files storing database information to some other location, whether on disk or some offline storage such as tape. Physical backups can be made with either the Recovery Manager or MAN. Database recovery. Database recovery is the process of restoring the database to the most recent consistent state in the event of a failure. The failure may be the result of a system crash due to hardware or software errors in the program that is accessing the database. Recovery restores a database from a given state, usually inconsistent, to a previously consistent state. The database recovery process generally follows a predictable scenario. First, it determines the type and extent of the required recovery. Suppose the entire database forward recovery or redo. Forward recovery is the recovery procedure which is used in case of a physical damage. Whenever there is a crash of dispatch, failure during writing of data to database buffer, or failure during flushing buffers to secondary storage. From this buffer, data is transferred to and from secondary storage of the database. Backward recovery or undo. Backward recovery is the recovery procedure which is used in case an error occurs in the midst of normal operation on the database. The error could be hardware or software errors, or system crashed and leaving some changes to the data. Media recovery. recovery is performed when there is a head crash, that is, record scratched by a phonograph needle on the disk. At the time of head crash, the data transaction. A sequence of many actions which are considered to be one atomic unit of work is called transaction. Customer pays with credit card. Merchant captures credit card information. Upon approval by card issuing bank, the merchant account is credited and the transaction is submitted for settlement. Back-end processor pays the acquirer and debits the card issuer account. Transaction is sent to issuer. Acquirer funds the merchant's account. Issuer posts the transaction to the customer's account. Customer receives statement and pays the issuing bank. A transaction is a logical unit of work. Start statement, begin transaction. End statement, commit. Execution errors, rollback. Redo and undo. A transaction is an action or a series of actions carried out by a single user or an application program which reads or updates the contents of a database. A transaction must have 4 properties called asset properties to ensure that a database remains stable after the transaction is executed. Atomicity. A transaction is an atomic unit of processing and they do not have parts. They cannot be executed partially and it should not be detectable that they interleave with another transaction. Consistency. The transaction must take the database from one consistent state into another. It is the responsibility of user to ensure consistency. During transaction at the middle, the database might not be consistent. Isolation. Transaction recovery. A transaction starts by executing a begin transaction operation and ends by executing either a commit or a rollback operation. Commit establishes a commit point, also known as a sync point, especially in older systems. A commit point thus corresponds to the successful end of a transaction and hence to a point at which the database is supposed to be in a correct state. Rollback, by contrast, rolls the database back to the start state it was in at begin transaction, which means back to the previous commit point. The phrase "the previous commit point" is still accurate even in the case of the first transaction in the program, as tacitly establishing an initial commit point. When a commit point is established, all database updates made by the executing program since the previous commit point are committed. That is, they are made permanent and guaranteed to be recorded in the database. Prior to the commit point, all such updates must be regarded as tentative only. Once committed, an update is guaranteed never to be undone. System recovery. The system must be prepared to recover not only from purely local failures such as an overflow exception within an individual transactions, but also from global failures such as a power outage. A local failure affects only the transaction in which the failure has actually occurred. A global failure, by contrast, affects all of the transactions in progress at the time of failure and hence has significant system-wide implications. Such failures fall into two broad categories: SQL support in backup and recovery. Structured query languages SQL support for transactions and hence for transaction-based recovery follows the general pattern described in the foregoing sections. Most executable SQL statements are guaranteed to be atomic. The only exceptions are call and return. SQL provides direct analogs of begin transaction, commit and rollback called start transaction, commit work and rollback work respectively. Here is the syntax for start transaction. Start transaction, transaction characteristics. The option comma list specifies an access mode, an isolation level or both. The access mode is either read-only or read-write. If neither is specified, read-write is assumed. Unless read and committed isolation level is specified, in which case read-only is assumed. If read-write is specified, the isolation level must not be read and committed. The isolation level takes the form isolation level, isolation, where isolation is read and committed, read committed, repeatable read or serializable. The syntax for commit and rollback is commit work and no chain, rollback work and no chain. Work is a noise word and chain causes a start transaction with the same option comma list as the previous one to be executed automatically after the commit, and no chain is the default. A clause is executed automatically for every open cursor, thereby causing all database positioning to be lost, except for commit, only for cursors declared with hold. A cursor declared with hold is not automatically closed at commit, but is left open, positioned such that the next fetch will move it to the next row in sequence. The possibly complex repositioning code that might otherwise be needed on the next open is thus not required. SQL also supports save points. The statement save point name. It creates a save point with a specified user chosen name which is local to the transaction. The statement rollback to save point name undoes all updates done since the specified save point, and the statement release save point name drops the specified save point, meaning it is no longer possible to execute a rollback to that save point. All save points are automatically dropped at transaction termination. Example for commit command. Consider the customers table shown in figure. Delete from customers where age is equal to 23. Commit one row from the customers table with age is equal to 23 will be deleted. Select statement will produce the result as shown in figure. Example for rollback command. Consider the customers table shown in figure. Delete from customers where age is equal to 23. Rollback. As a result, delete operation would not impact the table. Select command would produce the following result. Example for save point command. Consider the customers table shown in figure. Save point SP1. Save point created. Delete from customers where ID is equal to 1. One row deleted. Save point SP2. Save point created. Delete from customers where ID is equal to 2. One row deleted. Save point SP3. Save point created. Delete from customers where ID is equal to 3. One row deleted. Now that the 3 deletions have taken place, say user have changed their mind and decided to roll back to the save point that user identified as SP2. Because SP2 was created after the first deletion, the last 2 deletions are undone. Select statement would produce the following result. Summary. In this class, we have learnt about transaction recovery, system recovery, SQL support in backup and recovery.